Hello everyone, Meteorologist Matt Holiner here, and for today's weather extra, I want to talk about making a forecast. That's the part you never see. You always see the end result after we've made the forecast and we're presenting it to you. But making the forecast takes up a big chunk of our day, and it's really the hardest part of our day too. It's never easy to make a forecast, and I want to try to explain why that is. So the first step to making a forecast is having an accurate picture of what's happening in the atmosphere right now. You have to know what's occurring in order to project how it's going to change with time. And so to sample the atmosphere, we use a lot of tools. We use satellite data, radars, weather stations, and weather balloons. And the weather balloons are very important because not only do you need to know what's happening in the atmosphere at the surface, but at different levels of the atmosphere. You need to know what's happening 10,000 feet up, 30,000 feet up. What are the temperatures like? What is the wind speed? Where's the jet stream at exactly? Because where the jet stream is has a big impact on how the weather is going to change. But the problem is, even though we have a lot of observation data, we don't have enough. For example, we don't have a weather station in every single town in the United States, and more specifically, every single home in every single town in the United States. So there's certainly some gaps in data, and it gets worse in other countries, especially poorer countries that don't have as much resources. There's some significant lack of data and weather stations and weather balloons that are launched. And especially with those weather balloons, there's also gaps in how frequent those observations are, because you need as many observations in as many locations as possible. And for those weather balloons, for example, right now they're launched by the government, and the government only has budgeted for those weather balloons to be launched twice a day, 12 out, just every 12 hours. And that's not good enough, because we need to know how things are changing more rapidly than that. But currently, they're only launched twice a day. So because we don't have enough current observations, we have to estimate what's going on in between those weather stations and in between those gaps in times. And that's really the first problem, and why forecasts aren't more accurate is just we don't have a good enough sampling of the weather. You need as accurate a picture of what's happening right now in the atmosphere as possible. But we do with what we have, and so we take those current observations and the estimates of what's happening in between, and we plug those into these complex models. And the equations really are what's powering these models. And it's these equations that take those current conditions and project how those current conditions are going to change with time. Because there are no perfect equations, these equations are very good. It's amazing how accurate they are, but there's no one equation that can always accurately project what the forecast is going to be and how these current conditions are going to change with time. So we make slight variations to these equations, and that's how we come up with our different computer models. They all use the same equations, but with slightly different versions of those equations and slightly different estimates of our current observations. So we get forecasts like this. These are looking at models projecting temperature with time. And notice that we have more models in a shorter amount of time in the near future. As we go farther out with time, this is looking at the next 7 days, we don't have as many models to choose from. And what's also worth noting is how they vary the farther out. In the short term, notice the models are in pretty good agreement about what the temperature is going to be. But once you get beyond 72 hours, notice that the NAM is one model in red, and the GFS, another model in blue, have a much different opinion on what the temperature is going to be. So what do? Well, as a meteorologist, we have to try and figure out which model is doing the best. And sometimes we can do that. It especially works good in the short term. But as you get farther out, it gets harder to tell which model is doing the best. So a lot of times what we do is taking the average of what the models are saying. And that's represented by that white line there. That shows what the average temperature is of those models, the average forecasted temperature. But even that doesn't always work, because see those black dots there on the left? That's what actually happened, what the actual temperature was. So all the models were too warm. It was actually colder than what the models were saying. And so that's where we come in as meteorologists. It's like, okay, the models are too warm. It's warmer than they're saying it's warmer than it actually was. So when we're making the forecast for 12 hours out, it's like maybe we should forecast temperatures a couple degrees cooler than what the models are saying, since so far the models have been too warm. So that's how we still come in handy as meteorologists, not just all computers. but they certainly are our biggest tools when we're forecasting the weather. And these are the maps that I look at when I'm making my forecast. Now, this is assuming that I'm making my forecast on a Wednesday. So when I'm looking at Tuesday at 2 o'clock, we're talking about 7 days out, next Tuesday at 2 o'clock in the afternoon. And there's really only two models that we look at that far out for days 6 and 7, especially day 7. The European model, the ECMWF, and the American model, the GFS model. And notice, this is why we don't have a lot of confidence when we're making a forecast for 7 days out, because we only have two models to look at, and sometimes they don't have any agreement on what's going to happen. This is actually not too bad, but as you can see, the American model has a lot more rain than the European model. So what do? You kind of take an average and kind of go with maybe a medium chance of rain based on this. But compare this to what we have when we're making a forecast for the same day. I'm making a Wednesday morning, I'm making a forecast for Wednesday afternoon. I have 6 different models that I can look at. And I'll tell you what, those 3 at the top are better resolution models, especially the HER and the RPM. But those only go out 72, 36 hours. And so we don't have those in the long term. They're good models. They're actually surprisingly accurate, but they just don't go out very far. In order to be that accurate, they just can't go out very far. The amount of computing power it takes to run those models is so much that they can only go out a certain amount of time. So the hope is that one day we'll get better models, higher resolution models that will go out farther in time. But right now it's mainly in the short term. But I want to stress is that as it stands now, we always have more confidence in the short term because we have more models to look at, and notice they don't vary as much. Yes, there's still variations. That's why there's always some degree of uncertainty in the forecast, but in general, the models are in better agreement shorter out than farther out. So the next time you look at the 7-day forecast, I want you to imagine these words on top of the 7-day forecast. Notice that for days 6 and 7, we want to show it to you because, to be honest, that forecast is getting better, a lot better than even 20 years ago. We have a lot more confidence in that forecast than we used to, but I do have to say that as it stands right now, you have to keep in mind that our confidence is still low. There could still be a lot that changes. Those temperatures could certainly go up or down. The amount of rain could certainly go up or down. It's kind of just a general idea. That we show it to think, hey, it's going to be getting warmer, it's going to be getting wetter, it's going to be getting cooler. That's the way you should think about it. Even days 4 and 5, really just medium confidence. We never have high confidence in the forecast until 3 days out. And notice we don't have very high confidence until 24 hours out. So I always tell people, if possible, don't cancel your plans until 24 hours out, because then we have very high confidence. If you do have to make plans earlier than that, earlier than 24 hours, don't adjust your plans more than 72 hours out. If you cancel your family picnic next Tuesday because we have a 70% chance of rain, you might regret that, because it might look like 70% chance of rain right now, but that could certainly change. So really don't adjust your plans until at least 72 hours out, even better 24 hours out if that's possible. One last thing I want to talk about, what does chance of rain mean? Because it seems to confuse a lot of people, so I'm going to try to bring some clarity to that. Remember, and a chance of rain, when we say a 50% chance of rain, that's a 50% chance of rain for the entire view area. We're making a forecast for everybody in the valley, not just you at your specific location. So when we say there's a 50% chance of rain, that means we think half of the valley is going to see rain. But that also means that we think half of the valley is going to stay dry and not see rain. So keep that in mind. Even when there's a 70% chance of rain, that means 30% of the valley is going to stay dry. And also remember that a 50% chance of rain does not mean it's going to rain for half of the day. That's certainly not the case. Chances are it's going to rain for a much shorter amount of time than that, because all that chance of rain means is the chance that you will see a trace amount of rain. It's not a forecast for the amount of rain. So an 80% chance of rain means that it could just mean that you'll just see a little bit of rain for a short amount of time. An 80% chance of rain doesn't necessarily mean it's going to be a really rainy day. So keep that in mind as well. If we think there's going to be heavy rain, we'll let you know. If we think a certain part of the valley is going to see more rain than another part, we'll also be sure to let you know. So I hope you found this interesting and you have a better understanding of rain chances now and how difficult it is to make a forecast. Thanks for watching.